Hello, my name is David Ackerman, 220310629, and this is the assignment W3. So the givens are that the tank A has the initial pressure of 250 kilopascal, the mass of zero point 0.5 kilograms, and a XA value of zero point 0.1, which is the vapor ratio. Now, the pressure of tank B is 200 kilopascals, the temperature is 400 Celsius, and the mass is also zero point 0.5 kilograms. Now, on the final state, the temperature for the both of them is 150, and the pressure 2 is 200 kilopascal. So from table A5, we get these values using pressure 250 kilopascals. We get all these specific volumes and energies, internal energies. Using VG and VF, we get VFG, which we use this. Then using VFG, we use this formula which is to find the volume of A, which we're not given. And using the internal energies, we can find the internal energy of A as well. Now, with the volume of A and that we calculated and the mass of A, we can calculate the volume of A total. Now, after the assumptions that we're having is that the quasi-equilibrium, so we can use work equals pressure times the change in volume, and we assume that pressure equals 200 kilopascal in state 2 is a constant pressure. So this right here would be our final pressure. This is the diagram where we add work and heat and we go into stage 2. So there's only two states. Continuing, uh, the temperature saturated at 200 kilopascals is 120.21 Celsius. And now because temperature B, which is 400 Celsius, is greater than this, we're in the superheated region. Now, using table A6, we can know that pressure B equals 200 kilopascals or zero point 0.2 megapascals, and temperature B equals 400 Celsius. We can use it to find volume of B and internal energy of B. Now, to find the total volume of B, we just have to use the same formula, which is volume of B that we found here, times the mass that we're given, and we get the B total volume. Now, to get the total volume of 1, we have to just add the volume of A total plus volume of B total, and we get this volume specific. Now, total energy of volume 2, we use table A6 for the same ones, but temperature is 150 this time because that's temperature 2 after the whole reaction. And we get the volume 2 equals 0.959 meter specific volume. And with that, we add both masses and multiply that by the volume 2 that we found using these two tables, these two values on table A6, and we get the volume 2 total equals this. So this would be the total volume. Now, to find the work done, we have to because we assumed quasi-equilibrium, we would be able to use these formulas. This formula right here, which is the volume for total work, which is pressure 2, which is given as 200 kilopascal, times the change in volume, which is going to lead to 29.754 kilojoules. Now, in heat transfer, where we would use table A6 with yet again the final temperature and the final pressure to get um the final internal energy, and the heat transfer would be equal to mass times the change in internal energy plus of A mass of B times the change of internal energy of B plus the work done, which we will calculate to 755.624 kilojoules. So in the end, the final pressure is 200 kilopascals, the final volume is 0.959, the total work is 29.754, and the heat transfer is 755 kilojoules. Thank you.